All floors that are manufactured, especially for dance, have to meet certain manufacturing specifications in order to be sold to dance schools and dance companies as dance floors. And one of the most important specifications of a dance floor is that of the floor's force reduction, or it's also known as the floor's shock absorption. Shock absorption. And this is obviously a really important property of a floor because it represents the amount of energy that the floor absorbs and really how much spring the floor has to help the dancer to when they land and also hopefully to help them when they jump. So in this video we'll look at how force reduction is recorded, how is it measured, and what are the specifications that a floor needs to meet in order to be sold as a dance floor. So the first thing you need to do, or to start with when you want to measure force reduction, is a thing called a drop mass. Okay, a drop mass. And a drop mass I have used to represent this funny looking grey box and the spring down here above the two floors. And it is just as it sounds. It is a mass that you drop onto the floors. And basically what you use the mass to do is to measure the force associated with the impact on the floors. And there's certain standards and criteria that if you're going to measure a floor that you need to abide by so that the test is standard and is uniform and is reliable. So the first thing you need is a 20 kilogram mass. So the grey block here is normally quite a solid piece of metal which weighs 20 kilograms. You need a spring of a certain stiffness, and you need to typically drop the mass in around about 50 millimeters or so, depending on the standards. The American standards compared to the European standards can vary a little bit. And basically you drop the mass onto the floor, and when the mass hits the floor there's an impact, and as you're well aware now, we have what a ground reaction force come up from the floor. Ground reaction force. And effectively that is what the measurement does, is that it's measuring the ground reaction force coming up from the floor from this standardized impact that comes from the drop mass. And to get a baseline measure, the first thing you do is drop on this floor here in the middle, which we can say is concrete, and that gives us our baseline force, which is typically for a 20 kilo mass dropped at that height around about 6,000 newtons. So 6,000 newtons is a measure of force, and it equates to around about 600 kilograms. So it's quite a big force that occurs within a relatively small drop. So it puts quite a big impact through the floor. So now we have a baseline, we can go and measure a test floor. And we go along and we take the drop mass across. And of course it's standardized. We have the same 20 kilograms, we have the same spring, we have the same height, and we drop the mass down onto the floor. The force is typically measured by a little sensor that sits in the foot here, or a sensor that is measuring the acceleration of the mass that sits up here in the actual mass. But either way, it measures the force. And then, of course, we have a ground reaction force coming up out of the floor. And for today, let's say that on this test floor, we're getting a reaction force of around about 3,000 newtons. So we have a peak force on a test floor, we have a peak force on concrete, and to get the force reduction of the test floor, we just compare the two. So with a peak force of 3,000 on the test floor compared to a peak force of 6,000 on the concrete floor, we would have a force reduction of 50%. Because the test floor has effectively reduced the peak force by 50%. 3,000 is 50% of 6,000. And for a test floor, the standards, they can vary a little bit, but typically the minimum force reduction that you can have is between 40 to 50%. And the maximum force reduction that you can have in a dance floor is around 65 to 70%. And in the studies that I've done interviewing dancers about the floors that they prefer, I can tell you that they really like these high-end force reduction floors. These are probably a little bit too hard. The lower force reduction floors are probably a little bit too hard for dancers, and the dancers tend to prefer the high force reduction up to 70% or even a little bit beyond 70%. I've had measurements of dancers who really prefer something up around 75, even closer to 80% force reduction. But when you're getting up in these higher levels, so if we're getting up to 80 plus force reduction, then you're getting a really, really springy floor. We're getting lots of movement through the floor, lots of deformation, and it can become a little bit unstable. And so you lose that control or that feel from the floor that's really important in dance. So the force reduction or the shock absorption of a floor should be listed in the specifications of a dance floor manufacturer's specification sheet. They should have gone through these standards and had the floors tested so that they are acceptable for dance use. So if you're ever looking into getting a new floor, ask for the specification sheet and have a look for either what is listed as the force reduction or the shock absorption, and see how it measures up. Because obviously these properties are really important to help a dancer to perform and also hopefully to prevent them from becoming injured.